Welcome to this lecture on aspects of climate and environmental change in the history of the Mongol Empire, which is part of the course on the Mongols and global history initiated by Francesca Pegolloti from the University of Vienna. And I also would like to thank Francesca for this opportunity to present some aspects of the climate and environmental history of the Mongol Empire. Especially climate aspects of the Mongols' history were quite prominent in the last years in the media. For instance, these are two headlines indicating how climate helped the Mongols or Gengis Khan to establish their empire. And these ideas stand in a long tradition that climate change or environmental changes initiated the movement of nomadic people from the steppes towards sedentary empires. And this goes back to antiquity in two aspects. The one is that already ancient authors claimed that people moved towards, for instance, the Roman Empire since environmental conditions in their original homelands deteriorated. So we have this tradition almost as a topos, as a motif in many works of historiography. And on the other hand, also modern day research made such claims. This is, for instance, a study from 2013 by Edward Cook, one of the leading figures in especially tree-ring-based paleo-environmental research. And he claimed on the basis of the reconstruction of precipitation conditions in the steppes, on the basis of tree rings from a region in China, that, for instance, the Huns in the 4th century were motivated, so to say, to move due to a long mega drought, as he calls this, between the 330s and the 370s. And that similar droughts would have also initiated, for instance, the movement of the Avars in the 6th century. So in this scenario, it is especially a deterioration of climatic conditions in the steppes which motivate the movement of nomadic people. Along similar lines, Pei and Zhang in 2014 published this paper trying to show a strong correlation between changes in precipitation, so when conditions became more arid, and the movement of nomadic people towards the Chinese borders, and then the conflicts emerging between the nomadic invaders and Chinese rulers, and that there would be a strong correlation between the climatic change and these aspects of political history. However, the headlines I have shown before are related to a different scenario presented by Neil Patterson and his team in 2014 in this paper published in PNAS. They tried to demonstrate, on the basis again of the reconstruction of precipitation conditions in Mongolia at the time of the rise of Genghis Khan, that especially in the period between 1211 and 1225, when we see that the strongest growing of Mongol power under Genghis Khan, that this was a period characterized by very moist, humid, and warm conditions, so a very beneficial climate, which would have promoted high grassland productivity and favored, as they say, the formation of Mongol political and military power. So that Genghis Khan expansion was benefiting from these better climatic conditions, which were without parallel over the last 1,000 years. But equally interesting is their finding that in the 1180s, the Mongol steppes suffered from one of the most severe drought periods. And this was overlapped with the years of the rise of Genghis Khan to power, which were characterized by very strong infighting wars between different groups, as we know from the secret history of the Mongols. And in this scenario, it would seem as if, again, these bad climatic conditions would have aggravated socio-political crisis in Mongolia, which eventually then led to the rise of Genghis Khan. The findings of Patterson were somehow confirmed by a different study by Aaron Putnam, published in 2016, on the basis of data from the Tarim Basin, now in northwestern People's Republic of China, which indicate that from the 1180s onwards, there was a rise of the groundwater surface in this otherwise very arid area, which would have, for instance, brought about a southwards expansion of grassland, which would also have been to the benefit of the expansion of a nomadic empire like that of the Mongols. So these are new findings which would indicate that the rise of the Mongols, under Genghis Khan at least, was somehow benefiting from better climatic conditions at that time. The question, however, is how climatic conditions work in the interplay with socio-political conditions. So how a specific climatic parameter would bring about or would contribute to socio-political change. And this is a big question in all these attempts to reconstruct environmental history of the past. And last year, a very interesting paper was published by Shultz and Costopoulos, trying to show with the help of a computer simulation how simple mechanisms of environmental change interplaying with socio-political change could have brought about a firmer nomadic empire in the steppes. And for this purpose, they used agent-based modeling. So a very simple model, which shows on a surface, and we can also start here this. You see here, it's moving, an animation of this simulation. So you have on the surface, which somehow simulates the steppe, you have households, which have herds of different size, and they encounter beneficial or non-beneficial environmental conditions, which would contribute to the growing or decreasing of the number of the animals. And if a household falls below a specific threshold for the number of animals, it would ask another richer household to help them with animals. And if this richer household would give animals to the poorer household, this would establish a patronage link, so a network. So the richer household would then have the opportunity to establish a patronage network, a network of followers. And this very simple model with various parameters tried to simulate the possible impact of changing environmental conditions on the growing and establishment of networks among steppe households. And their findings or the results of this model indicate that better environmental conditions would lead to higher inequality. So there would be a bigger difference between a big number of poorer households and a few very well-off households. But at the same time, this would allow for more opportunities for the formation of larger and more durable networks. So the better the environmental conditions, all would profit, but some would profit more. And this would increase the possibility for, say, the big players also to establish a bigger and more durable patronage networks as basis of their power in the steppe. This is, of course, a very simple model, but at least it attempts to show a possible simple mechanism how better environmental conditions could have benefited to the emergence of larger and more stable power formations in the steppe. As I have said, these reconstructions for the Mongol steppe are very much based on tree rings. So tree rings as one possible climate archive. I think here it's relatively clear how this works because trees grow with a different strength from one year to the next based on the precipitation and temperature conditions. And these differences in the growth can be used to reconstruct temperature and precipitation conditions of the past. You see here one example, and also here reconstruction, for instance, on the basis of tree rings for late medieval Austria. So there is a growing number of such data, hundreds and thousands of such tree ring data across Europe and Eurasia, which allow for very refined reconstruction, also on a bigger spatial scale. Here, two examples, again initiated by Edward Cook, whom I've mentioned before. To the left, you see the Old World Drought Atlas, which is a reconstruction of summer precipitation conditions in Europe and the Mediterranean for the last 2,000 years. And for every year, you can look at the reconstructions and see how, in this reconstruction, of course, the precipitation conditions were different from one region to another one. And to the right, you see the counterpart for East Asia, the Monsoon Asia Drought Atlas, which unfortunately only starts in 1300, because before that time the data density is not sufficient enough. But at least say for the late history of the Mongol Empire, also this data can be used to some extent. Tree rings are only one among several archives of nature, as the Swiss pioneer of environmental history, Christian Pfister, has called them. And these archives of nature, these are natural phenomena whose composition, chemical composition, or whose strength of growing, for instance, like in the case of tree rings, depends on climatic conditions. And these various archives of nature, you see here the list, and you can also download the entire presentation. There's the link at the bottom, where you can also look at the slides later onwards. You can see these various archives of nature. They cover various phenomena, and they also cover various time spans. So it's also a question of temporal resolutions. Some of these, like tree rings, for instance, have an annual resolution, so you can really look at change from one year to the next. In other cases, for instance, pollen normally, you can look at the long-term trend, so from 1 century to the next. So that's normally not an annual resolution. So of course that also indicates to what extent you can make scenarios on this basis for which periods these archives can be used. And the counterpart of these archives of nature would be the archives of society. So this would especially be written sources. This can be direct observations, so it's in a text of historiography about weather conditions or extreme events like droughts or floods, but also indirect data. So observations on plant phenology, for instance. A famous example is the registration of the beginning of the cherry blossom in Japan, which allows, for instance, to reconstruct spring temperature in Japan since the 9th century. So for more than 1,000 years, because you have continuous observations. So this would be the archives of nature and the archives of society. Of course, both archives have their limitations. As I've already said, it's about temporal resolution, but also spatial coverage. So regarding temporal resolution, it's also a question of the density of evidence. So here you see here at the bottom a reconstruction of another attempt to reconstruct winter temperatures in Europe by Edward Cook, and you see here how the number of data points which can be used is decreasing significantly the more you go back into the past. That's one problem, and the other one is the spatial uneven distribution. You see here at the top a map of a global reconstruction of paleoclimate, with some dots indicating various kinds of proxy data. And you see by those, for instance, the blue areas, which are sometimes thousands of kilometers away from the next proxy data, which of course limits the explanatory value of this data for these regions, which are far away from any place where data was found. But that's also similar for the archives of society. As you see at the top, that's, for instance, maps from the 9th to the 14th century of extreme weather events reported in Byzantine sources. And as you can see, we have a lot of information on the weather and events around Constantinople, the capital, but large areas of the empire are not covered to the same extent. And at the bottom, you see a map of the density of meteorological information from Arabic sources for the medieval period. And again, you see here There is a high density of information for the capitals, Baghdad, Cairo, Damascus, but for large areas of the Arab Peninsula, for instance, there's no information at all. So this means that both these archives of nature and of society have their limitations, which you have to be aware of if you make use of them. This also means that for this kind of research, you need a close cooperation between natural sciences and humanities historians who are able to know the limitations of their respective archives and to bring them together in order to create a more robust scenario for a specific area in a specific period, for instance. So on the basis of this paleoenvironmental research over the last decades, this is more or less the reconstruction of the global trajectory on the northern hemisphere of temperatures for the last 2000 years. And you see an up and down of average temperatures. And these periods have also been named according, say, to the temperature conditions. So in antiquity, in late antiquity, we have a transition from the so-called Roman climate optimum, which was a rather warm period, from the 3rd, 4th century onwards towards a cooler period in late antiquity. This cooling of the late antiquity then changed in the 9th, 10th century towards what is called the medieval climate optimum or the medieval climate anomaly, again on average a warmer period. Which then from the mid 13th century onwards and in the 14th century gave way to what is now called the Little Ice Age, a very cold period which lasted until the 19th century, where we have then the onset of the now anthropogenic modern warming period. So this is the overall trajectory, but this is the global average, which is very different and very diverse if you look at the specific regions at specific periods. So we always observe a high regional diversity within this global average, one could say. What we can see is that this medieval climate optimum or anomaly, at least in Western Europe, seems to have been beneficial for demographic and economic growth, as can be also seen in the number of cities established or in the number of religious foundations. So you have various statistics which show that this was a period of demographic and economic growth up to the 13th century. And now at the beginning of the 13th century, these growing societies and polities encounter a new threat, and this is the Mongol invasion. So after first campaigns already in the 20s, when Gengis Khan was still alive, we then see the big campaigns of the 1240s, which lead to Mongol invasions to not only of Eastern Europe, but also of Central Europe, 1241 invasions both in Poland and in Hungary. But whereas Russia and Eastern Europe then came under permanent Mongol control, Mongol armies retreated from Central Europe and did not occupy permanently Hungary, for instance. And this is up to this day a puzzle. Why didn't they occupy, especially Hungary, which is the westernmost part of this Eurasian steppe belt and would also have been suitable, especially for nomadic lifestyle? And to answer this, there is also, again, an attempt to answer this with climatic conditions, which also made it into the media. So in 2016, we, for instance, read here this headline, "Did climate fluctuations save Europe from the Mongol hordes?" So this headline is based on this paper published by Ulf Bündgen, a leading figure in paleoenvironmental research, and by the historian Nicola di Cosmo, a very prominent historian of the steppe empires. And they published this paper on climatic and environmental aspects of the Mongol withdrawal from Hungary in 1242. So why did the Mongols, after they had occupied Hungary, after they had defeated the king in 1241, why did they retreat from the Carpathian Basin in 1242? And on the basis of 3 rings from the Austrian Alps and from the Romanian Carpathian Mountains, they, Bündgen and Di Cosmo, tried to demonstrate that after several years of very arid conditions, the year 1242 became extremely humid, so a big number of precipitation, of rains, and this would have made both the campaigns more difficult, so the area was less suitable for military campaigning, and also it would have deteriorated the grazing conditions, so that also the logistics of the Mongol army were interrupted. So the Mongols could no longer supply their army in the Carpathian Basin, and these bad weather conditions then motivated the Mongols to retreat from the Carpathian Basin and from the Kingdom of Hungary. So did nature stop the Mongols in 1242? This is the scenario of Bündgen and the Cosmo. Of course, thereby they would create a Western counterpart to the more famous story of the stop of the Mongol invasions of Japan. The Mongols from China in 1274 and again in 1281 tried to invade Japan with big fleets coming from the Korean Peninsula, and in the second attempt also from southern China. And in both cases, we learned this also from Japanese sources, a large part of these fleets was destroyed by severe storms, typhoons, which the Japanese then called divine winds, kamikaze, which then later, of course, was also used in World War II in a different context. And this would be one very well-known example. There are also non-archaeological findings of remains of the Mongol fleets, how nature stopped the Mongol invasion of a country. However, the scenario of Bündgen and the Cosmo was not accepted, especially not in Hungary, and a number especially of Hungarian historians under the lead of Zsolt Pinke in the same year, in 2016, published a replique to the article of Bündgen and the Cosmo, and they tried to demonstrate on the basis of written sources they had analyzed that it was clear that the Mongols had already established a government in Hungary, that they intended to stay there, that also the more humid conditions in 1242 were actually beneficial for the grazelands and for the agricultural output, and for this purpose Pinke and his team use data of the productivity of the Hungarian basin from the 19th century, and that also the marshy terrain due to the precipitation would have not impeded the Mongols, who then on the contrast settled down the core of the empire in Eastern Europe in the swampy regions around the Volga Delta. So this all would contribute to the idea that these more humid conditions in 1242 were no obstacle for the Mongols. Based on this paper, then Bündgen and de Cosmo also made a reply, published then in 1217, where they more or less try to confirm the scenario. They say that the data which Pinke and his team used are not convincing, especially the data on the productivity of the grasslands from the 19th century cannot be used for the conditions in the 13th century, and so we stand by our conclusions, as they say. And this debate then continued, and last year then Stephen Pau, who was one of the authors of the paper published by Pinke, wrote a long article again about the possible impact of weather and climate conditions to the Mongol withdrawal, confirming more or less the ideas also published in 2016 against the Bündgen and the Cosmos scenario, also trying to demonstrate that the Mongol armies encountered much more adverse weather conditions during their campaigns in various regions, which did not impede their campaigns, so that it is improbable that these conditions in 1242 would have hindered their further expansion. So it's still unclear actually why then they withdrew from Hungary in 1242. And he also tries to show that the written sources for 1242 do not actually narrate anything about adverse weather conditions impeding the Mongols, in contrast to the second Mongol invasion of Hungary, which took place in 1285, where there are descriptions of adverse weather which led to famine and epidemics in the invading army, which then eventually would retreat from Hungary again. And these scenario of power now is also somehow confirmed by the most recent systematic and massive survey of medieval floods in medieval Hungary, published by Andrea Kiss in 2019. And she does not register a flood event for 1242. So according to her analysis, there is no indication that there was really a big flood or adverse conditions to this regard in this year. But again, in 1285, there is such a description when, now under the command of Nogai Khan, who at that time ruled the westernmost parts of the Golden Horde Empire, Mongols and Cumans invaded Hungary again. And here, for instance, a Viennese chronicler registered that God sent on them clouds and great rains. Cloudburst in spring caused such a great flood that almost all of them suffocated. And we also have other descriptions that these armies suffered from adverse weather conditions. So in 1285, one could say weather contributed to the stop of the Mongol army, whereas in 1242, this scenario, according at least to this more Hungarian-based historians, this was not the case. But one could say the debate is still open. So whereas the Mongols retreated from Central Europe in 1242, they occupied large parts also of the Middle East under the command of Hülegi. In 1258, the Abbasid capital of Baghdad was conquered, and the Mongols also were on their march towards the west, towards Syria and Egypt, but were stopped in 1260 by the Mamluks, who had taken over the power in Egypt and defeated the Mongols in the Battle of Ain Jalut, which then stopped the Mongol expansion also there. So we have also here a limit to Mongol expansion towards the west. So this is then the extent of Mongol power in around the mid 13th century. So a huge empire from the Pacific to the Mediterranean to Eastern Europe, which however then became divided, as is well known, under various lines of the descendants of Gengis Khan. We have then four empires of the Golden Horde in Eastern Europe, the Ilkhanate in Iran and Iraq, the Khanate of Chagatai in Central Asia, and then the Yuan dynasty, Kublai Khan and his descendants in Mongolia and China. But despite this division, still a one united space was created due to Mongol expansion, which led to what is called the Pax Mongolica, so an new world order under Mongol rule, which intensified the connectivity between different regions across Afro-Eurasia. So an intensification of what one could call early globalization, an intensification of exchange and mobility between these areas of the old world. Just one example, this is the route from Tana at the Black Sea to Kambalik, Beijing, described in the handbook of the Florentine merchant Francesco Pegolloti from the 1330s, who describes how it is possible over several months to travel from the Black Sea to the center of Mongol power in China, also indicating that Marco Polo was not the only one traveling along these routes. So this is the peak of Mongol power, one could say, in the late 13th and early 14th century. But as I have said before, the same time is also characterized by a transition of the global climatic regime from the medieval climate anomaly towards the so-called Little Ice Age. And this transition starts in the mid-13th century and is characterized again globally by a decline of average temperature, and this transition period is also characterized by an increasing number of weather extremes. Not only cold, but also droughts, so all kinds of weather extremes, which is normal for such transition periods in climatic regimes. We can also see this now in the modern day climate change period. This transition to the Little Ice Age, also for this transition, the Mongols have been made responsible. You see this in this headline from 2011, How Genghis Khan Cooled the Planet. This headline is related to this paper published by Julia Pongratz and her team in 2011 about coupled climate carbon simulations and the effects of wars and epidemics on atmospheric carbon dioxide. And this is based on an early idea, which was especially initiated by William Ruddiman already in 2003, who tried to show that human activity already before the modern period had an impact on climate. So that the Anthropocene, the period, the geological period when humanity has this enduring impact on the geology and on the climate of the planet, already started before the 20th century. And in Ruddiman and also other scholars have had here 2 points where they wanted to show that already there was a human impact. One already was the beginning of agriculture in the Neolithic, so 10,000 BC. So when, due to the growing scale of agricultural activity, more carbon dioxide was emerging into the atmosphere, and this would have contributed already since then to a warming after the end of the last ice age. And the other scenario proposed by Ruddiman was connected to the European expansion into the Americas, which led to large-scale death of indigenous population, especially of epidemics brought by the Europeans to the Americas. And this would have led to the loss of agricultural lands and to the growing of forests. And these forests would have accumulated more carbon dioxide from the atmosphere, and this would have contributed to a cooling, which then, for instance, can be shown as peak of the Little Ice Age in the 17th century. So these are these 2 scenarios. And along these lines, also now Pongratz and her team tried to evaluate the possible impact of other events of large-scale population losses. So they also have here the conquest of the Americas, the possible impact on the carbon dioxide budget, one could say, of the planet, and possible contributions to cooling. And they tried to analyze this for the Mongol invasion, for the Black Death, for the conquest of the Americas, and the fall of the Ming Dynasty. And 2 of these scenarios are connected to China. So, for instance, especially the Mongol invasion. So they calculated that, for instance, of the 150 million inhabitants of China, 30% died because of the Mongol invasion. And then this would have led to a decline of agricultural activity, a growing of forests, and a decline of carbon dioxide in the atmosphere. So this is the scenario. However, even on the basis of this data, they came to the conclusion that none of these events would therefore have affected atmospheric carbon dioxide concentrations by more than 1 part per million. Only the Mongol invasion could have lowered global carbon dioxide, but by an amount too small to be resolved by ice cores. So we have here 2 problems. On the one hand, already the basis, the quantitative basis, is guesswork. We don't really know what was the demographic effect of the Mongol invasion, and also these numbers may indicate not only loss of population but also loss of control over population, that not all of these people die but not longer show up in the text registers. So that's one problem. And the other is that even according to this rather maximalist scenario, the effect of the Mongol invasion, even if we assume that 30% of the population in China died, was rather minimal. So that the Mongols, Gengis Khan, the cooling of Gengis Khan, did not really contribute to the emergence of the Little Ice Age. We have to account here for some mechanisms of non-anthropogenic climate change. One is the fluctuations in the activity of the sun, of solar activity. Higher solar activity is normally indicated with a higher number of sunspots. And if there is a decline or even a minimum of sunspots, so that almost no sunspots are observed, and we have observations of sunspots, for instance, in China going back to the 12th century, that such minima in the number of sunspots indicate a reduced solar activity, which would then lead to also a reduction normally of average global temperatures on our planet. And we see that the beginning and also throughout the Little Ice Age was characterized by several of such minima, starting from the mid-13th century onwards by the so-called Wolf minimum, where almost no sunspots have been observed. So that's then, say, extraterrestrial impact. And another possible contributor to climate forcing are volcanic eruptions. So major volcanic eruptions change the composition of the atmosphere, of the higher layers of the atmosphere, especially the particles and the gases ejected. and they would reduce the number of solar radiation which can make it down to the surface of the Earth, and would also contribute to a cooling. Normally, this effect is limited depending on the size, on the scale of the eruption. So, for instance, you see here data, the impact of the Pinatubo eruption in the 1990s, which had a global impact, but only for a few days or for a few weeks. But major eruptions can also have really a longer impact. For instance, in 1815, there was the eruption of the volcano Tambora in Indonesia, which then led to the so-called year without summer, where really for months the atmospheric conditions really were much cooler and led also to bad harvests all over the United States and Europe, for instance. So we observed a longer effect of such larger scale eruptions. And this obviously also took place in the mid-13th century in 1257-58. We have description here, for instance, in an English source of such a year without a summer, which would have impeded the growth of plants, also led to a very bad harvest, to famine, and then also to the outbreak of an epidemic in that year, so that a lot of people died. A mass grave from these catastrophe was also identified some years ago when there were construction works at the St. Mary's Hospital in London, which is to the north of the Hyde Park. So we have here this description also in England and in other regions, that this was a catastrophic year with very extreme weather conditions. And these were already for some years ago connected to an eruption of a volcano, but it was not clear which volcano was responsible, so it was called a mystery eruption. But then some years ago, geologists identified or tried to date this eruption in this period for the volcano Samalas on Lombok, an island in Indonesia again. And this is now more or less the scenario that an eruption of the Samalas in 1257, whose remains can still be seen on the island, was responsible for this catastrophic year in 1257-58. And as you can see on this graph, this was one of the most severe eruptions in the last 1,500 years. But again, the Little Ice Age was characterized by a cluster of such eruptions, and also throughout the period there were several large-scale eruptions, which on top of the reduction of solar activity may have served as catalyzers of this climate transition. Of course, these change of the average conditions, so which then would lead to cooler or drier conditions, and also an increase in the number of extremes, also had an impact on societies. The most prominent, maybe, which is always also in the media, is the end of Viking settlement on Greenland. The Vikings had settled Greenland in the 10th century when there were more beneficial weather conditions, and then from the 13th and especially the 14th century, the temperatures declined on average, and also especially the amount of sea ice around Greenland increased, which impeded maritime connections, and these colonies were very much depending on a constant flow of goods they could not produce on Greenland from Scandinavia. And these connections were now very much impeded, and this obviously then contributed that eventually the settlements were given up in the late 14th or in the early 15th century. For Europe and Afro-Asia at large, I would like to refer to this book you have already maybe seen in an earlier unit of this course by Bruce Campbell, published in 2016, The Great Transition, who really established a very sophisticated scenario, combining historical evidence with paleo-environmental evidence, but also paleo-epidemiological evidence, to really show this complex interplay between nature and societies, which led to this change or to this crisis of the 14th century. And one example here, already analyzed in earlier studies, is this big famine crisis in Northern Europe in the years 13, 15 to 17, where there is especially very good data from England indicating the amount of the reduction of the harvest, the rise of the grain prices, and then the impacts on society. So growing number of deaths, a declining number of marriages, but also, for instance, a growing number of crimes. And this can be connected to a series of very, very humid years with a lot of rain and extreme humidity in northwestern Europe. So you see here the reconstruction from the Old World Cloud Atlas for summer 2015, indicating the extreme humid conditions in that year, which did big damage to the harvest and then contributed to the socio-political crisis. This crisis then in England and in other regions of the continent was aggravated by the arrival of an epidemic, not of humans, but of cattle, an epizootic. And on the basis of written sources, Bruce Campbell reconstructed that this epidemic arrived from Central Asia. Then from the late 13th century onwards can be observed in Eastern Europe, and then made it via also trade connections to Central Europe and eventually all the way to the British Islands. And this episodic also for sure affected the steppes and the Mongol polities in the steppe in Eastern Europe, in Central Asia, and also in Mongolia. We will refer later to it. And for sure, especially also for the nomadic parts of these populations were a big problem, but also contributed to the aggravation of the agricultural crisis in Central and Western Europe. And this trajectory of this diffusion of this epidemic then more or less is the first indication of how these stronger connections across Afro-Eurasia now also made it easier for pathogens to travel across larger distances. And of course, then is also the basis for the big catastrophe of the mid-14th century, the outbreak of the Black Death, which in 1346 then became first visible for European observers on the Crimea, and then via the maritime connections was transported from the Crimea to the Mediterranean, then all across Europe. The maritime connections being the counterpart to modern day air travel, one could say. And there was a long debate which was the pathogen, so which bacterium or virus was responsible. And this has been solved in the last 15 years with a growing number of paleogenetic discoveries in mass graves from various waves of the epidemic. So after the first wave, the epidemic recurred in Europe up to the late 17th century, or for instance, the Ottoman Empire up to the 19th century. And it is now clear that the pathogen of the Black Death is Yersinia pestis, so the plague bacterium. And it was also possible to establish a phylogenetic tree, so to sort out how this pathogen is related to other families of the plague bacterium and from where it came to the Mediterranean and to Europe. And one of these findings is also in Central Asia, where this grave is already dated to the late 1330s, so it's again indicating and confirming the description of the written sources that the epidemic came from Central Asia to the west. And this paleogenetic evidence now made it clear that these plague bacteria have still relatives, one could say, in the Qinghai Tibet Plateau, so in modern-day People's Republic of China, where relatives of this plague bacterium are still endemic in regional rodent populations. So this is obviously the plague focal point where these pathogens emerged and then traveled across wider areas. So the bubonic plague as such is endemic in specific flea populations, which then are depending on various rodent populations. So especially in these natural plague regions in Central and Eastern Asia. And these fleas, who are carriers of the pathogen, can also then be transported to other mammals, especially also mammals or rodents which live near to human populations. And then these disease then can also affect humans via flea bites, for instance. But secondary to the bubonic plague, there can also then emerge pneumonic plague, and pneumonic plague can then be transmitted directly from one human to the next. And pneumonic plague is especially fatal, so normally 90 to 100% of people die. In the bubonic plague without any treatment, normally the lethality rate is around 60%. But you can also see in this graph already these cycles of transmission are also influenced by climate. And the scenario is that in these areas where the pathogen is endemic in rodent populations, if there's a change of climate conditions, if there are more humid conditions, this would lead to an increase in the number of fleas and also of rodents. So we have an increased activity of circulation of the pathogen, and this then would have also increased the probability that the pathogen can jump over from the rodent population to rodents living near humans, and from then on to human population, and from then can be transmitted especially also by human activity to other regions. And this is what seems to have happened in the mid-14th century, where we see also this change of climatic conditions, which would have benefited the increasing number of pathogen carriers in these regions. So that is the scenario which can be reconstructed now. And so this zoonosis, this endemic disease within the rodent population in Central Asia or in northwestern China then became a pandemic which affected human populations and was especially spread across the trade routes and the intensification of trade routes under the Pax Mongolica in the decades before. And this can be connected to this intensification of global connections and to also characteristics of such complex global networks. An example from modern day, this is a reconstruction of the global air traffic network. And as you can see, this is a very unequally distributed network. So there are zones which have a high density of connections and very peripheric zones, and there are also hubs. So central nodes where many connections come together, which are connected to other hubs. So for instance, Frankfurt Airport with JFK in the United States. And these inequalities in this connectivity are also more or less based on the efficiency of these networks. If we stay in terms of global air traffic, it would not make sense to send half-empty air carriers from any airport in Germany to any airport in the United States. What happens normally is that you take a flight from Düsseldorf or from Halle to Frankfurt. So from the smaller airports, the passengers who would like to travel across the Atlantic are collected at one hub, and then you have a direct connection from Frankfurt to JFK, and from there you have onwards flights to all other places in the United States. So more or less. And this is still more efficient because it brings together the various streams of travelers, and at the same time it means that only in 2 steps, with 2 times changing the airplane, you can get from any place in Germany to any place in the United States, more or less. So these complex networks create small worlds with a very few steps, number of steps you can get from any place to any other place, but they also create inequality and contribute to the emergence of these central hubs via which these streams and connections are distributed. And this is contributing to the efficiency, but it also eases the spread of unexpected passengers like a pathogen. So for instance, if a pathogen emerges even in a peripheral place, once it reaches one of these central hubs, it can spread across the entire network very quickly. And these hubs, for instance, are the big airports. And we see such a phenomenon, for instance, the last time in 2000-2003, when there was the outbreak of SARS, the severe acute respiratory syndrome, which was also caused by a coronavirus, a relative of the virus we are struggling now with. And this disease also emerged in southern China, and then became a global phenomenon once the pathogen reached the hub of the airport of Hong Kong, and from there spread across the entire planet. At that time, this disease was rather mild if we compare it with what we see now. Most of the outbreaks were in southern China, and the total number of fatalities was around 1,000, most of them confined to China. So there was, although it was globally distributed, there was no widespread global outbreak outside of China. This changed, however, with the coronavirus responsible for COVID-19. This is the map created by the Johns Hopkins University, which you most probably have seen already in earlier in the media over the last weeks. And this is the state of the disease at the end of January, when it was mostly confined to China, with not yet 10,000 people infected and 213 deaths. But unfortunately, in contrast to the coronavirus in 2002, 2003, this became a global pandemic. This is the map from yesterday, with more than 1 million people affected and more than 76,000 deaths. So, but you see also here the pattern of outbreak from China then across the planet, especially also, of course, via air travel. And we don't have such accurate maps, of course, for the Black Death in the 14th century, but also here we see a global diffusion process across these global networks via the land routes and then especially the sea routes all across Afro-Eurasia. The question is now, to what extent these phenomena also affected the Mongol polities. So we see that the disease also spread towards the Mediterranean from the Black Sea and over towards the Middle East, affected, for instance, Tabriz or Baghdad, so the centers of Mongol power in Iran and Iraq. But at that time, Mongol power in Iran and Iraq had already fragmented. After the death of the last Ilkhan, Abu Sa'id Bahador Chan in 1335, the Ilkhan-Empire had fragmented in various regional power centers. So the central power was weakened also during the period of Abu Sa'id, but after his death, then more or less the empire broke up in various polities. So the plague already affected a region which was highly politically fragmented. But as we have seen already before in the 14th century, climatic and environmental conditions had aggravated socio-political crises across various regions in Europe, for instance. And also for the Mongol Empire in Iran and Iraq, such a claim has been made already in 1993 by Peter Christensen in his book on the decline of Iran Shah. And to a certain extent, it can be confirmed with new data. This is a reconstruction of precipitation conditions in northern Iraq on the basis of speleothems, so dripstones from Kuna Bar cave in northern Iraq. And here we can see that, for instance, in the early 14th century, we have a series of drought periods. So these conditions may have also aggravated the socio-political crisis which had already emerged in the Mongol realm in Iran and Iraq. This means that we already see also from the written sources that there was a crisis of power and of the cohesion of the regime. So this was not caused primarily by climate or by adverse climatic conditions, but of course then the problems emerging from these adverse conditions aggravated the socio-political crisis and then contributed to aggravation of the problems of the realm, and such way also contributed to the fragmentation of Mongol power. So this would be a possible scenario in this case. As we have seen for the Europeans, the Black Death emerged from the realm of the Golden Horde. There's this famous story that when the Mongols besieged the Genoese colony on the Crimea in Kaffa, that they catapulted plague-affected dead body into the city, and this would have been the outbreak of the disease for the Mediterranean and Europe. What is more probable is that on the basis of these intensive trade connections, where the Crimea had become a hub between Central Asia and the Mediterranean, that this was the background for the spread of the disease. But in any case, the Golden Horde areas were also very much affected by the plague, as we also learned from the descriptions of Western observers. One interesting phenomenon is that the plague spread first already in 1346 in the steppe regions, which were under the direct control over the rulers of the Golden Horde, whereas to the Russian territories, which were under the sovereignty but not under the direct control of the Golden Horde, the disease only then spread later in the early 1350s. And this has been connected to the phenomenon that the Mongols had issued a travel ban, so that inhabitants of these Russian princedoms under their overlordship were not allowed freely to travel to the steppe regions, the core regions of the Golden Horde, and this would have created a corridor or a barrier for the spread of the disease, so that only then, when the disease had affected the Baltics, via the trade connections, then it also came to the Russian princedoms. So that's one scenario. But in any case, the disease for sure affected also the Golden Horde, as also the cattle disease in the early 14th century had affected the Golden Horde. So all these also contributes to the environmental parameters. So the 14th century for sure was also, from an environmental point of view, a crisis period for the Eastern European territories of the Golden Horde. This is also a reconstruction of the frequency of droughts, other extreme events, and especially of famines on the basis of written sources published by Vladimir Klimenko in 2010. And you see here that also the 14th century, as in other regions across Afro-Eurasia, was a period of an increased density of such extreme events and on famines. And also this is a reconstruction of the winter temperatures in Eastern Europe. We see also, as was the global trend, that also climate conditions became colder in the 14th to the 15th century, also in this region. And this scenario has also been confirmed with more recent data, for instance, in the study of Ulf Bündgen from 2013. So one could say also the Golden Horde territories followed the same less beneficial trajectory as other regions across Afro-Asia. But at the same time, we have to say, and this is also a scenario or a phenomenon we see in other regions, that although all these territories or these regions were affected by these adverse conditions, some polities were able to come to terms with these challenges to a better extent, or even to profit from the weakening of their neighbors. This is also the case in the for the Golden Horde, because the Golden Horde from the mid-14th century decreased in power, and we see the emergence of new power centers at the same time who are expanding at the cost of the Golden Horde, especially Muscovy, Moscow, and the Grand Princedom of Lithuania, both expanding towards the territories formerly under control of the Golden Horde. And this would then culminate in the case of Moscow in 1380, where the troops of Moscow then defeated the Mongols in the Battle of Kulikovo Polye. So here we see the rise also of new power centers, despite being also affected by similar extreme events. So we also have an outbreak of the plague in the Russian princedoms, for instance. So this also demonstrates that we should not follow climate deterministic models, so that this specific climate conditions would always lead to this socio-political outcome, but that the same or similar conditions can also have different responses by different societies and then lead to different outcomes. And this we can see, for instance, in this region very well. But one possible explanation also is why still, for instance, Moscow or Lithuania were able to expand at the cost of the Golden Horde, is that maybe also, for instance, drought conditions affected this region in different ways. This is a reconstruction of summer drought in 1400 from the newly published European Russia Drought Atlas, which was published in early 2020 by Ed Cook and his team. And for instance, you see here that this drought very much affected the areas under direct control of the Golden Horde along the Volga and in the steppes to the north of the Caspian and the Black Sea, whereas the areas to the northwest of Lithuania and of Moscow were much less affected, or even had good precipitation conditions. So also maybe these regional differences to a certain extent may have also contributed to the weakening of the one side and then the better position of the other side. But again, only in combination with specific frameworks of power, of also the organization of military and social power. Climate alone cannot explain this, but we can see how it can intensify specific benefits or specific differences also in power between polities. In the early 15th century and late 14th century, we also have then the final, one could say, blow to Golden Horde power coming from, again, a Mongol neighbor. And this is the last attempt to establish Mongol power in Western Eurasia by Timur Lenk, who claims to be a descendant of Gengis Khan, who from 1370 onwards, from his power center in Samarkand, then leads devastating campaigns to Iran, Iraq, to India, and also to the territories of the Golden Horde. So the capitals of the Golden Horde are plundered and destroyed, and this contributes to the ultimate then weakening of Golden Horde power, which then also fragments in various khanates on the Crimea and Astrakhan and so on. So this is more or less also then after the death of Timur Lenk, also his empire fragments, and this is the end, one could say, of the peak of Mongol power in Western Eurasia. So we can see for the Western Mongol realms in the Ilkhanate and of the Golden Horde, we also have similar crisis phenomena which can be connected to the climate change from the medieval climate anomaly to the Little Ice Age. Again, as I said, not in a deterministic way, but aggravating already evolving crisis in the organization of power and so on. One realm which is left, which was the biggest and richest Mongol polity, is the one of the Yuan, of the Mongol rule in China. And here it's also clear for years now that the Yuan in the 14th century encountered also, as in other regions of Afro-Asia, an increasing number of climate-induced challenges. 2010 already, Timothy Brook published this book, The Troubled Empire, which also has a very interesting overview on climatic and environmental challenges, both for the Yuan and also for the following Chinese dynasty of the Ming. And this was also observed by contemporary historians. In the Chinese traditions, this increasing number of extremes is also connected to the sighting of dragons. So the dragons were seen in the sky, and this was connected or seen as signs of coming calamities. And we also see this now in an increasing number of proxy data that also, like in Europe or like in Western Eurasia, also East Asia was affected by this transition from the medieval climate anomaly to the Little Ice Age, also with an increasing number of extremes. For a long time, there was also a debate if Black Death affected China, and Brook in 2010 was still skeptical. But also here we have an increasing number of paleogenetic evidence, and as I have said, the pathogen as such emerged in regions neighboring the core areas of China. So there's also now an increasing probability, and we also have descriptions of epidemics that also the Black Death or the plague affected the Chinese province. But before that, we have talked about this episodic, this cattle disease. And here we also have descriptions that already from the late 1280s onwards, such a disease affected the Mongolian steppes, and most probably then from their spread westwards all the way to Europe. This, of course, very much affected the nomadic people, the nomadic inhabitants of these areas, which were still under the rule of the dynasty of Gengis Khan, who was had their residence on the one hand in northern China, but were also traveling regularly to the Mongolian steppes. And here now, this disease contributed to socio-political or socio-environmental hardships for the inhabitants of Mongolia, and these were aggravated also by an increasing number of droughts and colds. So also here climatic conditions became less beneficial in contrast to what we have seen at the beginning in the rule of Gengis Khan. And especially, for instance, these cold periods contributed to what in the Mongol tradition is called Tsut. So this is the large-scale death of herds of animals due to extreme colds. This is from the Zut in recent years. So also in the recent years there was a large number of such events in Mongolia, and similar things happened in the early 14th century. And all this led to the phenomenon that a large number of households, of nomadic households, now migrated to northern China. Since the conditions in the steppes had become so bad, they tried to find help in the Chinese provinces, in the richer, agriculturally cultivated provinces, depending on the government. So the Mongol government in China, of course, now also had to help these people on which originally their power was based. And we see this then from the Chinese sources that a growing number of families, tens of thousands of such refugee families, had to be supplied for by the government. The problem was, however, that not only the Mongolian steppes were affected by this increasing number of calamities, but also the central Chinese provinces, especially along the Yangtze-Kiang River, which had become the breadbasket of China during the last centuries. And also these regions now were increasingly affected by extreme events such as floods, typhoons, droughts, and earthquakes. And you see, especially, we see a clustering of such events between the 1330s and the 1360s, which are also the last decades of Mongol rule in China. So the number of catastrophes was really exceptional, as also registered in the sources. And the government also now had to try to react to this. And here I refer to the article of Tana Lin, which has been sent to you by Francesca, and otherwise it's also for free download. You see here the link. And she has demonstrated in this recent article that also the Yuan emperors tried to execute measures of disaster relief. So they tried to provide supplies for these refugees from the steppe, for the people in the Chinese provinces affected by the floods and the droughts. So we see it also in the budget numbers, how millions millions from the budget of the state were invested in disaster relief throughout these years. Huge sums. It's also clear that the amount of material help the rich Chinese government provided is without parallel. No other polity at that time would have been able to do something at a similar scale, but still the dimension of the number of catastrophes was too big. So also then the government, the Yuan government, resorted to an already earlier used invention, which is paper money, since of course it wasn't possible to provide enough coinage, so paper money was issued. But the problem was the dimension of the crisis was so big that at the end it outperformed whatever the government was able to do in the face of these catastrophes. And this number of extreme events then, and these efforts of the Yuan dynasty then led to attempts to raise the necessary amounts of money by increasing taxation. But at the same time, the paper money as such was not longer supported by sufficient wealth of the government, which led to widespread inflation, which very much then also created economic turmoils. And all this also then contributed to the outbreak of a number of rebellions, especially again in these core regions along the Yangtze-Kiang. And this combination of extreme events, economic crisis, and then also fragmentation of authority ultimately then led to the collapse of the Yuan regime. Especially then from the south, one leading rebel who then claimed himself Emperor Hongwu, the founder of the Ming dynasty, then was also able to march towards the north. And then the last Yuan emperor had to retreat to the Mongolian steppes, so the Yuan had to give up China and withdraw to the Mongolian steppes, and this is the end of Mongol rule in China. Again, we see already before we have this increasing number of calamities, that the regime was weakened also via interfactional disputes. So the power basis was already weakened, but then again this increasing number of extremes aggravated this crisis and ultimately contributed also to the fall of the Mongols in China. So what we can see here is that throughout Mongol history, climatic aspects and environmental conditions played a role, contributed to various phases of expansion, but also contraction or crisis of Mongol power. But again, not in a deterministic way that this or that climate conditions would automatically create this or that outcome, but only in a combination with the responses and dynamics within a specific socio-economic framework, this or that outcome then can be observed. Nevertheless, these are also debates which are still ongoing, and an increasing number of data will also lead to new scenarios. So also in this general trend of the growing importance of environmental history, the Mongol Empire is really also a prominent case which has to be taken into consideration. So finally, Mongolia today. Also Mongolia today is affected by the current climate change. You see this is the reconstruction of precipitation conditions from the same study of Pedersen, who claimed that Gengis Khan profited from humid and beneficial conditions in the early 13th century. And you see here, for instance, in the early 2000s that the biggest drought period for the last 150 years affected Mongolia throughout this time, which then also was connected also with very severe winters at the same time, with an increasing number of Zut events, which led to the death of millions of animals in the Mongolian steppes. And the bad news is that according to the reconstructions of the growing temperatures or the changing climatic conditions under modern day climate change, the probability of such drought events, but also of such Zut events, will increase in many areas of Mongolia. So this will be a severe challenge for also the traditional nomadic lifestyle. Already after these Zut events, thousands of households in the last years gave up their traditional lifestyle and migrated to the capital of Ulaanbaatar. And we will see how this will affect over the next decades the traditional steppe lifestyle, which is again challenged also by climatic conditions. And with this outlook, I would like to finish this lecture. I thank you very much for your attention. I would like to thank Francesca once more very much for the invitation. And as I've said, there's also a link below where you can download the slides. And I hope that this was of interest. And if you have questions, you can also easily contact me via email.